Hi everyone, this is Ray. Today I'm going to introduce you to my Goldberg machine, and I'll explain each and every step in the machine while I explain all the energy transformation along the way. So the machine will start off here when I release the ball. The ball will travel down the ramp and hit the dominoes. The dominoes here will has the kinetic energy to travel and eventually will hit the mousetrap. The mousetrap, which has elastic potential energy, will be released and cause the wooden box beside it to drop and hit the hammer. And the energy transformation between these two steps is from the elastic potential energy back into the kinetic energy. The kinetic energy eventually will hit the button right here, which has spring inside the little box. Once it is initiated, the box will shoot out the ball, which is turning the potential energy back into kinetic energy. The ball will travel along the track through this tunnel, and at the end will hit the dominoes and come out on this side. The dominoes will hit the ball, travel along the track, eventually hit the dominoes at the edge. When the dominoes is knocked over, it will turns from potential energy into kinetic energy when it's falling. Since it is attached to the string, the kinetic energy will cause the wooden block to be removed from the ball. And once it is removed, the ball will turn the potential energy into kinetic energy. It will travel along the track down to this dominoes made of books, and eventually the book here will drop, which is the potential energy of this book. It will hit the wooden stick and cause the other edge to lift up. This edge right here, it is attached to a match. The match itself, which has chemical potential energy, and once it is rubbed against the box, it will cause fire, and that is the thermal energy. The thermal energy will travel along this string, and the string will eventually go all the way up to the cup and burn out the string of one side. And the cup, since it is weighted, it will be released and swing to the other side of the room. This transformation is the potential energy of the cup into kinetic energy. And when the box is moved, the ball will drop. That is the potential energy of the ball turned into kinetic energy. And the ball will travel on the track down the edge of the box and then eventually hit the stick underneath. The stick itself, once it is hit, it will turn the potential energy of this ball into kinetic energy again, and the stick will lift up and eventually cause the ball to be shoot up and down into the hoop. This is the final step of my Goldberg machine, and I hope you will enjoy it. Hi, for my Goldberg machine, there are two parts of video. I was forced to stop the first part of videotaping because the ceiling caught on fire, and I was forced to stop and put down the fire. And as you'll see in the end of the first part, you'll see that the machine didn't keep on going. So in the second part of the video, I interfused the machine and keep it going. So I hope you understand. Thank you. I'm going to start doing my calculation part of my Rube Goldberg machine. For my first question, I'm going to calculate the final velocity of this part of the video. For the total time it takes for this projectile motion, it are from 39.08 seconds to 40.2 seconds. So here I did a conversion here from time, and the final time I got is 0.76. And the time for projectile motion will carry on in either the horizontal and vertical. In this case, the time for horizontal and vertical are both 0.76. And these data, I got them from measurements. The horizontal distance is 0.4 meter, and then the vertical is 0.9 meter. Acceleration is a gravity, negative 9.8 meters per second squared. And I move on to the calculation. So what I did is I did the first part first, which is easier. So what I got, I used the formula displacements over time, and then I got 0.5263 meters per second forward. And then I move on to the vertical final velocity calculation. And notice that I cross off the VIY is because I only need I only need 3 known components to calculate the fourth component. So I used this formula. I got final answer, it's negative 4.9082 meters per second. Notice this is two-dimensional projectile motion, so I need to use the trig, which is this. The trigonometry, the Pythagorean theorem. I know that the y velocity and the x velocity, in order to get the whole system velocity, I need to use the Pythagorean theorem. So this is it, the formula, and then the final answer I got is 4.9363 meters per second for the final velocity. For the second question, I'm going to calculate the maximum height of the same projectile motion. To start off, I drew a graph of the projectile motion. From this graph, you can see the maximum point of this projectile has a velocity of 0 meters per second. This allowed us to calculate just this part of the projectile motion, and we can just neglect all the other part of the projectile. We list off all the variables that we can get from now. Vf, which is this point, the velocity will equal to 0 meters per second. Vertically, gravity has a negative 9.8 meters per second square acceleration to the ball. Later, this is the variable that we want to get at the end. And it leaves us to these two variables. For the time, it will be too hard for us to measure from the video, so we just cross it off, which leaves us to the VIY. The VIY of this projectile motion, we have to get all the variables from question 1. Here's a list of the variables. So we see these are time, acceleration, and displacement. So using this equation allows us to get the VIY at the end. So my answer is 2.5398. Then we move on to the next part where we use this the VIY to calculate the final displacement of the maximum point. And we move on, use the equation, sub in every number, and finally get this displacement of 0.3291. And for this displacement, it's just this part of the displacement. So this is the displacement we got from the calculation. In order to get the actual maximum point, we have to add the whole displacement, so which is this part of the parabola, with the actual height. So the answer will be 0.2291 plus 0.9, and you'll got 12291 for the total displacement of the maximum height. For number 3, I'm going to calculate the efficiency of this part of the video. For the efficiency, I list up all the formulas I need first, and then I figured that I need the mass, the height, and the velocity of the ball movement. So I break them down. First of all, I start from doing the potential energy. The potential energy, from measurement, I got the mass as 0.4 kg. The acceleration stays the same, and is 9.8 meters per second squared down, and the height is 1.54 meter it's the distance from the top of the box to the ground. So I simply plug in the equation, and then finally got 6.0368 joules for the final potential energy. For the kinetic energy, it is more complicated because we need mass and the velocity. So for this part, we have to extend more to find the velocity first in order to find the kinetic energy. I drew a graph first. I measured both sides of the projectile motion, figured out the displacement between these two objects, and I list out all the vertical components, and plug in this equation, and finally got 3.5140 meters per second down for the final velocity of vertical side of this projectile motion. Then I calculate the horizontal side of this projectile motion. So this is also from measurement, the time. I converted to seconds, and here I got 0.7632 meters per second forward. And finally, combined the two velocities together with Pythagorean theorem, and finally got 3.5959 meters per second forward but down. This is the final velocity of this projectile motion. And I plug back into this part of the question. So I plug in the velocity, the mass, and then I calculate out the kinetic energy of this motion. And then last but not least, I plug in the efficiency formula. So the efficiency for this system, the kinetic energy is the energy out, whereas potential energy is the energy in. So I sub in the equation, and then times 100, and then finally got 42.84% as the efficiency of this projectile motion. For question 4, I'm going to calculate the final velocity of this part of the video. And what I do, I start off with listing all the variables down. And since I know I'm neglecting the acceleration, I use this formula. And I just simply sub every numbers in and solve the equation. Finally, I got Vf equals 1.1904 meters per second down as my final velocity.